Hi, my name is Jonathan Morarity. I'm an electrical engineer at MicroVision, and I want to demonstrate you the MicroVision Phoenix Interactive Demonstrator. This uses our standard laser beam scanning technology to display RGB, red, green, and blue, visible laser light on a surface. This is actually demonstrating a tabletop surface projection. It could also be operated in a wall mode. But the really interesting thing about this is that we've now overlaid, while we're rastering out our red, green, and blue laser light, as you see here, we're also coincidentally scanning infrared light at the exact same field of view. And so what you see here is actually a laptop running Windows 10 and tablet mode. Any operating system is equally valid, but that's what we have here. And so there's a point cloud being generated, and it's actually measuring my finger in 3D space, and it's tracking a position associated with my fingertip. And so we've written a little bit of computer vision. There's a computer vision layer running, and it's set to actually inject touch events when the surface and the finger are approximately the same distance away from the transmitter. So here we have Fruit Ninja. Most people are pretty familiar with this program. Demonstrates the technology nicely. So a couple things to note is that you can track multiple objects simultaneously. 2 fingers, 4 fingers, pretty much as many fingers as you can fit in the field of view. There's no real limitation. Also, because this is a true 3D sensor, it doesn't just support touch. It'll actually support any kind of gesture that you can program it to recognize. So there's another classification set up here. Basically, my hand, as it passes from left to right, we programmed it to inject a keyboard event. That was the Windows key. It took me back to the home screen. So you can imagine that, again, if you're projecting up into space, any kind of gesture, any kind of touch, anything that you can do with a computer vision algorithm, you can implement with this technology. So another thing that's pretty important to point out is, because it's a time-of-flight system, there is only one mirror here. The same mirror that is scanning out the visible light is scanning out our time-of-flight pulses. And there's only one photodiode. So there's not a full infrared camera that needs to be placed and calibrated. Everything is sort of auto-calibrated with respect to the video content. There are some other products out there that emulate a similar kind of interactivity experience, but they typically, as I said, have a full infrared camera. It requires somewhat sophisticated calibration, and it also doesn't handle planar imbalances very well. And I'll show that in a second. The other thing is, for the touch registration, they use an IR light plane that's just some distance above the surface. And basically, if you were to throw other impeding objects into the field of view, that technology would break down, which with our technology, because it's a 3D scanner, there's no issue if there are other objects in the field of view, as long as you've written your finger classifier to ignore other objects. If you wanted to identify those objects, of course you could. This is just one example of rejecting them intentionally. So I mentioned that the 3D sensor will work on any plane. I wanted to show there's nothing special about that white background we had. It works on this blue at different orientations, different heights. It works on a dark background up to quite close, and it also supports curved surfaces. So we think this technology is pretty amazing. It's going to give you a tablet-type experience on any arbitrary surface, and samples of this will be available this year. Thanks.